Hello students, we are going to study chapter 1 of class 10 science, chemical reactions and equations. In this chapter, we are going to study what are the basic steps of writing a chemical reaction, why we need to balance a chemical equation, and the steps to simplify the learning of balancing a chemical equation. Let us revise some of the rules and some of the symbols of the elements which we have studied in class 9. For most of the elements, the first letter of their name is used as their symbols. For example, boron is represented by symbol B, carbon is represented by symbol C, fluorine is represented by symbol F, hydrogen is represented by symbol H, iodine is represented by symbol I, nitrogen is represented by symbol N, and so on. If the first letter of the name of elements are same, as in barium and beryllium both begin with B, then they are represented by the first and the second letter of their names. Barium is represented by Ba and beryllium is represented by Be. Similarly, if the first two letters of the name of the elements are same, for example in magnesium and manganese, Ma are their first two letters, then the first and third letter of their name are used as their symbols. So magnesium is represented by Mg and manganese is represented by Mn. There are various other criteria which are used for designating the symbols of the elements. Some were represented by their old or Latin names, some by the name of the country they were found from, some by the name of the scientist who discovered them, and some even by the name of the planets or other objects. For example, potassium is represented by symbol K, which is derived from a Latin word kalium. Sodium is represented by symbol Na, which is again from a Latin word natrium. And uranium is designated by the symbol U by the name of a planet, Uranus. Let us see what a compound is. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. So the chemical formula of compounds is a symbolic representation of its composition. It means it gives us the number of atoms of each element of which a compound is made up of. Here I have written two examples. Water with the molecular formula H2O has 2 atoms of hydrogen and 1 atom of oxygen. Carbon dioxide has 1 atom of carbon and 2 atoms of oxygen. Either we should remember the formula of the compounds or we should be able to determine the formula of the compound by the valencies, which we have studied in class 9th. Just to revise, the valencies of the elements are written below the elements, and by crisscross method, the formula of a compound is determined. Elements or compounds that undergo a chemical change are represented by a chemical reaction. Here, to represent a chemical reaction, I have used 4 letters A, B, C, and D. In the first reaction, you can see A and B are reactants, which are written on the left side. C and D are the products, which are written on the right side. They are separated by an arrow, which indicates the direction of the reaction. In reversible reaction, we have 2 arrows. The one on the top indicates the forward direction of the reaction, and the bottom arrow indicates the reversible direction of the reaction. For the forward reaction, A and B are reactants and C and D are products. But for the bottom arrow, C and D are the reactants and A and B become the products. Let us study about indicators of a chemical reaction. Indicators are signs that gives us an idea that a reaction has taken place. First indicator is evolution of gas. The second is change in temperature or heat. The third is change in color of the substances. And fourth is change in state of a substance. Some of the symbols which are used for these indicators we have already studied in our previous classes. For example, we know that symbol G is used for gas, symbol S is used for solid, symbol L is used for liquids. Let us know some more. An upward arrow is used for gas. A triangle in brackets is used for temperature or heat. AQ in brackets is written for aqueous solution. Aqueous means a solution in water. PPT in brackets is written for precipitate state. Precipitate means an insoluble state of a substance. An inverted arrow can also be used for a precipitate. There are some other ways by which we can make the chemical reaction more informative. This is by writing the pressure and the catalyst on the reaction. Pressure can be mentioned by writing it on or below the arrow of the reaction. It is mentioned in degree atmosphere. Catalyst is also written on or below the arrow of the reaction. Catalyst is not used in the reaction, but it is a specific compound which directs and increases the speed of reaction. Let us summarize what we have learned from this slide by these two reactions which are given below. Symbol G is used for gas. ZNO is the catalyst used in the reaction. The reaction takes place at 300 degree atmosphere and the product which is formed is in liquid state. In the second reaction, NaCl is in solid state, BaSO4 in liquid state. The compound which is formed as a product is a precipitate, so an inverted arrow is used for sodium sulfate. So these indicators must be used in a reaction to make it more informative. An equation can be represented in two ways. If the complete names of elements or compounds are written, then it is called a word equation. But if instead of names, the symbols of elements or compounds are used, it is called a chemical equation. Let us see what is meant by mole in a chemical equation. Mole is basically a collection of 6.022 into 10 to the power 23 particles. These particles can be atoms, molecules, or ions. In the reaction shown here, you can see 2 moles of NaCl are combining with 1 mole of H2SO4 to give 1 mole of Na2SO4 and 2 moles of HCl. What is the need to balance a chemical equation? According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. That means the total mass of the elements present on the reactant side should be equal to the total mass of the elements present on the product side. This can only be done by changing the number of moles of the elements or compounds on the reactants side and the product side. Let us learn some of the steps for balancing a chemical equation. After writing the correct symbols of reactants and products, count the number of atoms of each element on the reactant side and also the number of atoms of each element on the product side. Never change the number of atoms which are written as under or subscript in a molecule. For example, 243 in Fe2SO43 should never be changed. Only the number of moles can be changed. Like I have written 2 in front of Fe2SO43. Balance first the polyatomic ions. Elements which are single should be balanced in the last. And elements which are in fraction, the whole equation has to be multiplied with the denominator. Let us learn the stepwise method for balancing chemical equation. The first step is to draw boxes around each element or compound which are taking part in the reaction. Here we have drawn boxes around Fe, water, Fe2O3 and H2. The second step is to count the number of atoms of each element or compound on the reactant side and on the product side. The reactant side is the left side. So here Fe is 1, hydrogen is 2, oxygen is 1. Similarly, on the right side, Fe is 2, hydrogen is 2 and oxygen is 3. Now we'll select the atom with maximum number of atoms to be balanced first. Here we can see oxygen has 3 atoms on the right side. So we have to balance oxygen first. For balancing this, we will write 3 in front of H2O. After writing 3 in front of H2O, we see that oxygen is balanced on both the sides. Now what next to be balanced? We see hydrogen is 6 on the left side and 2 on the right side. So by writing 3 in front of H2, we see that our hydrogen is also balanced by 6 on both the sides. Now we are left with only Fe, which is 1 on the left side and 2 on the right side. To balance Fe, we write 2 in front of Fe on the left side, which is balanced by 2 Fe on the right side. Finally, we check the number of atoms of each element on the reactant side with the number of atoms of each element on the product side. We see the equation is balanced. You can check here that to balance this chemical equation, we have only changed the number of moles of the elements or compounds to balance this chemical reaction. If we have studied the steps of balancing the chemical equation carefully, we can see some of the chemical reactions require very few steps to balance them. For example, in this reaction, FeSO4 contains a polyatomic ion SO4. But there are 2 sulfurs on the right side. So to balance this, we just write 2 before FeSO4. And we see the whole equation is balanced in just one go. There are 2 Fe, 2 sulfur and 8 oxygen on both the sides. And the equation is balanced. Dear students, my next video, part 2 will be on types of chemical reaction. Please subscribe my channel and keep watching. Thank you.